Assalamualaikum warahmatullahi taala wabarakatuh and salam sejahtera. Thank you to organizer. My name is Faris Murshidi from Universiti Pertahanan Nasional Malaysia, UPNM. My research team, Wan Muhammad Syafwan and Neza Ismail from UPNM, Abdul Aziz Abdul Rahman and Saiful Aman Haji Sulaiman from UITM Shah Alam, and Rospi Mat Hussein from Polytechnic Sultan Haji Ahmad Shah Kuantan. I would like to present our research project is application of terrestrial laser scanner or TLS for three-dimensional 3D as-built indoor civil engineering department UPNM laboratory. For this content, for presentation, start with introduction, problem statement, objective, scope of work, methodology, results and discussion, lastly summary, conclusion and recommendation. Terrestrial laser scanner is the latest surveying valuable industry technology, mainly in the construction industry. And then the surveyor may do surveying works using TLS for a short time accurately. Terrestrial laser scanner also is a mobile grid volume 3-dimensional or 3D coordinate measurement system. It scans the range, double angle, which is a horizontal angle and vertical angle, and intensity of points at the sites. The problem statement for this study, firstly, the laboratories at the Civil Engineering Department in National Defence University of Malaysia or UPNM currently do not have an as-built plan. Then the next, the accuracy of the data using TLS is still in research. And then we come out with two objectives. First objective is to generate a three-dimensional model of as-built drawing UPNM Civil Engineering Laboratories from point cloud provided by terrestrial laser scanner. And then the second objective is to compare the accuracy of as-built drawing and actual data using a distometer. For the scope of work of this study, start with the study area that was located at Bangunan Bestari in UPNM at the Civil Engineering Laboratories, which is at Makmal Jalan Raya, Makmal Geoteknik, Makmal Reka Bentuk, and Makmal Hydraulic and Hydrology. The software and hardware was used for the hardware, TLS Leica RTC 360, and high performance laptop. And then for the software, we use Cyclone Field 360 for data collection, Cyclone Register 360 for data processing, and lastly is a Revit 2020 for producing 3D model. The data was used point cloud data derived by TLS, and the actual measurement data were acquired by using distometer. This is a methodology. The methodology starts with a preliminary study, which is start with a literature review on TLS, as-built drawing, 3D model, and identify the research topic, and then the software and hardware assessment. And next, I'll go through to preparation of the study, the software installation, site recce and equipment selection. And then we go to data acquisition, covering all the civil engineering UPNM laboratories using TLS Leica RTC 360. And then we use the distometer to measure the actual data. Then we go to data processing, download raw data from RTC 360, process using Cyclone. The point cloud was processed using Cyclone 360. And then export the data into Revit. Lastly, process the data to Revit to produce the 3D model. Then the result and analysis, we draw the 3D model and compare the measurement between the actual data and experimental as-built drawing. For the measurement of point cloud data, each edge of the object is selected to measure their measurement, like this figure, and then the process is applied to plan and side view to exquisite the complete data for height, width, and length for each object. The method of measurement for the study, we use the RMSE, will apply to compare the actual measurement with the acquired data measurement by TLS. The lower the RMSE, the more the accuracy. Then the results and analysis. This is a 3D model and S-built drawing of the whole laboratories. The laboratories consist of makmal hydraulic, makmal jalan raya, makmal CAE, makmal geoteknik, makmal reka bentuk, makmal elektrik, and makmal struktur berat. The walls, windows, door, and cornice are modeled and located exactly as the actual location. And then the S-built drawing of laboratories above are portrayed and drawn to the details. The furniture and assets in the laboratories are in order and follow the actual model in point cloud data. This is a 3D model of JKA laboratory for indoor. And then the analysis of measurements, the RMSE value for the laboratory, which is 0.0191 meter, is considered a good indicator of its intolerance range, which is below 0.02 meter. And then the highest error recorded for makmal hydraulic is fan diameter, which is that diameter is 0.09 meter. Meanwhile, the lowest error recorded for the same laboratory at makmal hydraulic is the height of table 2. The measurement is 0.001 meter. And then the study was concluded that the fan diameter has a higher error value because it is not located perpendicular to the room axis. Then through the measurement process in Revit, the user will measure according to the side view measurement, which is perpendicular to the room axis. Thus, the measurement that was recorded was not accurate due to the incorrect view. For the discussion, it is observed that the middle section of the laboratory is not modeled as the actual model due to the second story that is not included in the model. But furthermore, the laser scanner did not reach and cover the upper floor as the roof and ceiling block it. Thus, the model is only covered on the first floor. And then the machinery and experiment tools were not modeled in laboratory. The complex objects and assets such as LA operation testing machine, Marshall stability testing machine, shift shaker, and others are challenging to be modeled. Then the studies found that the wall thickness may be determined if the point cloud data is captured at both sides of the walls. And then the RMSE value is observed to be very good as the value is close to 0. It indicates that the TLS data is accurate and precise. And lastly, the higher error recorded in fan because the fan was tilted to the room axis. Moreover, the fan has curved shape at its guard. For the conclusion, it is concluded that the main objective of the study is achieved to generate a 3D model of S-built drawing JKA laboratories derived by TLS. Overall, the study managed to achieve LOD 300 for the whole 3D model. Next, the study concludes that the second objective is successfully achieved by comparing the accuracy of S-built drawing from point cloud data and actual data using a distometer and measuring tape. And then the RMSE value is observed to be very good as the value is close to 0. It indicates that the TLS data is accurate and precise. Thus, it is a handy and dependable tool to measure objects and assets indoor. For the recommendation, the study recommended researchers to conduct another study on the model 3D structure using software that will auto-generate based on the point cloud of the structure, especially the complex objects. And then the current software, Revit, could not model complex things. Therefore, the study also recommended researchers model 3D structure as detailed as possible to achieve LOD 500. That's all. Thank you.